Hey everyone, thanks for being here. My name is Andrew Kittredge. I am the Civic Innovation Lab Director at Beta NYC and part of the team that puts on Open Data Week. I'd like to start by thanking the Department of City Planning in particular for putting on these great in-person events. I've really been enjoying them so far this afternoon, and I'm especially looking forward to this one. New York City Open Data is a collection of free public data sets that allow anyone to learn about how New York City works. And Open Data Week is a celebration of that open data. It is co-organized with the Open Data team at the Office of Technology and Innovation, Beta NYC, and the ARC Collective Data Through Design. We kicked off Open Data Week on this past Friday, opening the latest edition of Data Through Design's exhibit corpus. New for this year, it's up not only through the entirety of this week, but next week as well. So if you didn't get a chance to check it out at the opening, you still have some time. We have a few other events this week. You can check out open-data.nyc to check them out, see what you might be interested in. And we are capping off the week with School of Data, which is Beta NYC's in-person conference on open data. If you've liked the events you've attended this week, I'd highly recommend get a ticket, check it out. It's going to be a lot of fun. And thank you very much, and I'll hand it over.
Hi, I'm Donnise Hurley. I'm a senior geographic analyst in the population division. So it's slightly different from what you've seen before when I don't have a picture of a cat, if you've been in previous presentations in this session. And also, in my division, we are the city's hub for demographic expertise. So it's, we're going to today look at ACS, so that's American Community Survey data, and ultimately we want to map it, and I'm going to show you a really simple way to map your data just using one line of code. But as you know, before we get to mapping, you actually have to process and analyze the data. So I'm going to walk you through that using the Public Use Microdata file. We're going to bring that into R and clean it up. So let's first, we'll start by talking about what is a public use microdata file. And then I will go over how to use the Census API to bring that into R. And then we'll do some data wrangling, cleaning up your file. And then we'll talk about PUMA vintages, which is just the word for saying the year the file was created, the boundary was created. And then we'll go over how to make a map. And I'll also plug one of our products to make sure that we are not misleading people with our maps. And so I'll show you how to map responsibly. Okay, so the American Community Survey is one of the Census Bureau's products. And so they send out a survey to about 3.5 million households in the US. And it's the most comprehensive survey, so we get demographic, economic, social, and housing data. So unlike the census, where they only ask basic characteristics, you get to know about educational attainment, transportation, employment characteristics. And because this is a survey, it's subject to sampling error. So you're looking at estimates, and that's important when we start mapping. We want to account for that, that error. And it's disseminated annually with 1-year estimates and 5-year estimates. And the 1 year is 12 months of data, and the 5-year is 60 months. So there's two main type of data products. One is the summary file, and the other is the public use microdata. And so the summary file, most of you are probably familiar with it. And these are pre-tabulated tables. So the Census Bureau creates tables based on what they think the user's needs are, and it's a very comprehensive list. The estimates are there, the margins of error are already calculated for you, so you just have to download the data. It's available, the 1-year file is for population areas with population of 65,000 or more, and then the 5-year data is for smaller geographies. So there's a trade-off. You get more geographic specificity, but it's less for less temporal resolution. In contrast, the public use microdata, that's the raw file, so you actually get individual records, and you get to see how individuals respond to the data. The Census Bureau adds some edits to it to protect the privacy of the respondents, but with that, everything you have to calculate yourself. So what's great about it is that you can customize the tables. You can determine which characteristics you're looking at, but there's an added complexity to it because you need to know how to manipulate the data. And one of the edits that they add is that it's only available for areas 100,000 population or higher. So let's take a look at the difference between the summary file and the PUMS file. So here we have foreign-born data for CD9 in Manhattan, and this is it's based on the question that asks, where were you born? So we can see here we have the estimates and the margin of error, and then you have a list of countries. So we're going to look at the same data in the PUMS file, and you can see that it's basically all in code. You have your serial number, and this represents a household, and then border is the number of persons in the household. Then we have the PUMA, and nativity is whether you are born in the US or born in another country. And these codes, this is the actual place of birth. And then we have our weights and our state here. So if we look at here, this is PUMA 4109, which is the same as CD9 in Manhattan. And there are 2 people in that household. One was born in Trinidad and the other in South Carolina. So you get additional detail in the PUMS file that you don't get in the summary file. But because of that detail that you have, you can only get it at the PUMA level or higher. So PUMAs are non-political geographies. They were created just for the collection and analysis for PUMS data. And so after each decennial, the boundaries are redelineated. They're based on the 2020 census tracts, or whichever the most current tract data. And so in New York City, what's great is that we approximated the community district boundaries. So here on the left, you can see the community districts overlaid of the PUMA boundaries. And when we delineated them for 2020, we have those boundaries even closer. So it's great. So if you need PUMS data, you can actually get something that's close to a community district, except in a few areas, such as Manhattan and the Bronx, where the community districts are quite small, so we have to combine them. And on our website, we have a crosswalk, so you can see the relationship between them. Okay, so it's very easy to pull data into R using the Census API. And so it's a very simple syntax. I prefer to use the Census API when I'm working with data. There are other packages out there, like tidyverse, if you are familiar with that. I find that I use the Census API instead of that because when the new data are released, you have to wait for the packages to be updated. And it's very simple to do it yourself. So you have your host name, which is the census URL, and then you just add the data year, the data set that you're looking at. So here is ACS, and then I want the 5-year data. And then you use the get function, and then you just add your variables, and then you add your geography. If you go to type in the host name, it actually gives you some examples, and you can see how to structure your API, and you can also get the table name. So quite easy to do. So you do the same for PUMS data. So the previous example was using summary file. So if I'm working in R, I just load my libraries. I use 3 from the tidyverse package. So, and then I add my key. So when you're working, you can go to this Census API site and register for a key. I add my variables. So here I have PUMA 10, PUMA 20, and so I list them like this because I'm actually going to write a URL. Scroll over here. So we can see that it's quite similar to if you wrote it out here. So this is the URL, and then I load it locally. I also call my replicate weights because those are needed to calculate standard error when working with PUMS data. So I've downloaded my data, and it's a bit messy. Just using R, I use a few functions. The name function to rename the column. So with the serial number, I take out the X in the periods, and then using gsub, I replace the brackets, and then I remove any unnecessary columns. Once I have my weights and I've cleaned up my weights and I've cleaned up my other files, I just merge them together to create a new data set. And this is just an extract from that. So it's cleaned up and it's ready to use. So you also have to recode your data. The Census Bureau has documentation on their website, and you can look at the data dictionary to see what the codes are. In this example, I'm just recoding nativity. Here you have your dummy variable, and then I'm renaming nativity, that's all in caps, and then I have it in lowercase. So whatever your the new variable is, and then you can see here that this corresponds to what's in the data dictionary. And then I take my data and I create a survey object, and this is so I can create my summary statistics from that. So this this is using the survey package, and so I'm not going to go into too much detail, but basically this is how you set up your survey object, and you're going to use that when you are making your summary statistics. So it's quite simple to follow. So this is the object that we created, and then I'm filtering on foreign born, and then the group by function. This is what I want my geography to be PUMA, and then sum up the foreign born column. And this is creating my standard error here. And I just, in this example, just called the first 10. And here we go. So it's quite simple and very easy. Like once you understand the syntax, and the survey package use a dplyr-like syntax, so it's very easy to follow. Okay, so PUMAs, like Lime, also have vintages. And so it's, the reason you need to know this is because sometimes files have multiple vintages, and that creates an issue. But you can see here that we have our 2020 boundaries and our 2010 boundaries on the left and the 2020 boundary. So the vintages are just the year that the boundary was created. So dual vintage PUMS files occur when you have data collected in two different geographies. So in 2022, that was the first year we had our 2010 and 2020 boundaries. So 2018 through 2021 uses the data were collected in 2010 boundaries, and the 2022 data use the current boundaries. We'll be using dual vintage PUMAs until 2026. So 2022, they released dual vintage files, but they surprised us in 2023, and they gave us the file that they already harmonized the data, which is really great. So initially, the focus of the presentation was how to deal with these messy dual vintage PUMAs. I still think it's important to know how to work with dual vintage PUMAs, because we don't know if they decide, hey, we're not going to harmonize this for you anymore, which could happen in the future. But also, if you're working with 2022 5-year data, it's good to know how to clean that up. So the first step in harmonizing the data is actually looking at the relationship between the two files. So I look at the geographic relationship between 2020 and 2010. So in this example, I'm looking at 4404 in 2020, that's highlighted with the blue boundary, and then the red boundaries for the 2010 PUMAs. So I disaggregate the PUMAs down to the tract level and look at the 2020 population for those. So here in this blue is the component of PUMA 4102 that's in 4403. And so I take that population, which is approximately 13,400, and divided by the total. I get a proportion from the total of that. So it's quite simple, and I take that new conversion factor and multiply it by the weight. So the person, household, and all of the replicate weights. And I do this because the weights is how you actually calculate the estimates. So I'm going to walk you through briefly of how to do that using the 2022 5-year file, because that's the most complex. So the process is quite easy, but there's some little bumps in the road just that people have had trouble with, and I think it's good to go over them. So the first thing that happened in 2022, they gave us 2 different PUMA geographies. So the data actually have to be down. So you didn't have a PUMA geography, you had a PUMA variable. So the data had to be downloaded for each PUMA. So you download first the data in 2010 PUMAs and then 2020 PUMAs, and then you do that for the replicate weights. And so these are commented out if you're looking at the syntax, and that's because I don't want things running behind the scenes while I'm doing this. So if you see the hash mark, that's what it is. So you do the same for the replicate weights. And so then I create a unique file for each vintage. And then I start working with just the first with the 2010 PUMAs and then 2020. I create consistent column names in making sure everything matches, because later I will merge the two files together. I'm importing the aspect ratio, so the conversion factor that I created. And you can see here this column. So I maintain these columns because they have, the Census Bureau also has a PUMA 10, and I want to keep that column. So that's why PUMA is just on its own, and then PUMA 20 is because we'll aggregate everything up to the PUMA 20 level. And then the conversion ratio is what will multiply the weights by. So joining the files together, I just use dplyr for that. And you can, here's the result here with the conversion factor. So I'm going to multiply this conversion factor by all of the weights. To make it easier, I just transpose the data using pivot longer so that I can just multiply. It's just easier to do it rather than having it in the wider form. Here you can see the results of each of the weights. And then, so this is the value PUMA 20 is what we're going to aggregate. And this is the result. So once it's been aggregated, I just merge it back with the original variables and then join it with the PUMA 20 and then proceed as usual. So it's quite simple. You're just multiplying your ratio by the weights and then aggregating it up to the PUMA 20. So now, getting to the actual purpose of this, we'll work with the same data set that we used before, the foreign-born data. And it's in PUMA 2020 boundaries. I'm using the map view package, which is, so if any of you have used Leaflet, it's sort of a wrapper for Leaflet, which is great because you can, it's less complicated than Leaflet, so you can make a map really quickly. And so I'm going to plug one of our data products. So it's different from map. So MapView is an R package created by Tim Appelhunt and his colleagues, but the population map viewer is where the population division has placed many maps using ACS. We have a few PUMS data for language. So visit our site if there's a map that you see a variable that you're interested in. The map is there. That's great. If you need to create your maps, then we can help you with that. So the map view package, quite simple. I use the simple feature library to convert the GeoJSON into a spatial feature. So you can download the data from bytes and then just convert it and merge it with the data. So the syntax for creating it is quite simple. You just add the data, and then the Z column is just what you're going to map. So it's quite easy, but it's very ugly. You can, I'll show you how to polish it a bit, but that's not really the purpose of MapView, is to create quick maps. And there are other things like Leaflet or, QGIS and ArcGIS if you want a really polished map. But even if you're exploring the data, it's important for you to make sure that you're not misleading anyone with your map and that the map is reliable. So I'm going to demonstrate our map reliability calculator that we have on our website. So this is the Population Division's website. Under Resources, we have Map Reliability, which is an Excel calculator, so you can see how reliable your map are. And the reason we use this is because ACS data have margins of error. And so when you're creating your classifications, they could fall within, you know, 2 different breaks. So you want to make sure that you're not having overlapping classifications, and that will mislead your viewers. Or if you're trying to make any inference from the map, it may be misleading. So I highly recommend you using our map reliability calculator when you're mapping any type of survey data. Quite simple to use. So in step 1, you just paste your estimates and your MOEs. Then you say how many classes. In this case, I'm using 6. And then you just, it's sort of like a game. You can start off and sometimes it's not reliable, and then you sort of get this reward feedback that you get this little indicator here that says your data are reliable. The lowest class is 0, and then the top class and then goes to infinity. So with these new reliable breaks, I go back to map view, and map view is it doesn't have the same customization as leaflet or other features, so you don't have an infinity. You can put in 0, but you actually have to place your top number. You can also do a sequence instead, but I prefer to use the @ function, so I actually can specify the breaks. And I added some colors and a hover feature. Oops. So you can, this map is, it tells more of a story than the first one that we saw. It's still not a beautiful map, but again, that's not the purpose of map view. And I'll go over some features that are neat. So you can sync 2 maps using leaf sync, which is great. You can see here side by side, not very beautiful maps, but one tells a better story than the other. You can change your base map, and I don't show it here, but you actually can link the legend with the data, which comes in handy when you're exploring data. And my favorite feature is a slider, and who doesn't love a slider? And it's very easy. You just add a pipe sign, which is fantastic. And just slide data. Everyone loves a slider. So I know I packed a lot into this. I mean, there some, it's a broad overview of some very complex concepts, but here for any questions. And you can also visit our website to see our data products, and we have a lot of reports to help guide people through understanding demographic trends in the city and the city's geography.
Any questions in-house?
Great job. I guess when we're doing the conversion from the old, let's say, PUMA to the new PUMA, Is there a margin of error when we're taking out like one PUMA and then we're adding it back in?
No. So so you're asking about the margin of error when you're converting it or creating the conversion factor?
Either.
So the conversion factor is based on 2020 census population. So so the decennial population is a full count.
Mm-hmm.
There's no margin of error associated with the census data. So the conversion factor, you don't have to account for. It's just looking at the proportion of the population that falls within each component part. Mm-hmm. So that doesn't have a margin of error. However, when you're looking at PUMS data, if you're converting it, you're actually applying it to the weight. I don't recommend, if you're using PUMS, I don't recommend you applying it to data that you've already processed. It's better if you use the raw data, because if you use it, let's say you have a table that you created, your MOEs will be inflated slightly if you do that. We have, I have a different formula for using already established estimates and MOEs, but with PUMS data, you can just re-download the data, so you don't have an inflated MOE if you're doing it that way. Yeah.
Next, we'll do a couple online questions. Two different people have asked, is there a GitHub or somewhere else where you have this code shared?
I am going to upload it to our GitHub account, and they can email me, or I think I posted the link on Open Data on the website, but I can see where it is. But I will be uploading it on the Population Division's GitHub, and probably the city, or the DCP's one as well.
And then one other online question, when would you use decennial census data over ACS data? So the decennial data is the gold standard. If you're just looking at basic demographic characteristics, such as total population, and basic housing unit counts, you want to use that, but it's limited. The ACS actually replaced the census long form, so if you need to know any type of social, economic, or housing characteristics, you're going to have to use the ACS. So let's say you want to know how many, what's the educational attainment of a certain group, or the poverty level, that's only in the ACS. So that's when you would use the ACS. But if you're just looking at total population, then you would want to use the census.
Any other in-house questions?
I might be asking almost the same question as the last in-house question, but I guess in that, it was just, I think maybe it just went quickly for me in the transforming from one geography to the other one.
Sorry.
So the building blocks are always census tracts? Like you never split a census tract?
No. So
that's the trick that you rely on.
I'll go back to that so we can take a look. So you're asking if, I'll just repeat it for online, but you're asking if we split census tracts when we're calculating the conversion factor, and we do not, because PUMAs are actually built out of census tracts, so there's nothing to split. It would be different if we are looking, when we were converting the census tracts from earlier, sometimes they are split, but PUMAs are built out of tracts, so there's no splitting involved. Here, we just overlay the boundaries and see where they fall and take that proportion and come up with the factor from that.
Follow up?
Sure.
And would you, you do a similar thing when you're doing the crosswalk to the community districts, or is that kind of just you take the closest matching? Is there a reason why you don't do
because, so community districts are political geographies, and they don't follow census tract boundaries. So we just try to throw them into where they fit. So that's why they don't have, the boundaries are slightly different, because they're created for different purposes. The PUMAs were created for data collection and analysis, and political geographies are what they are.
Well, we do have CDTA, right?
Oh, so we do, yes, thanks. Well, I'll plug that. So we have CDTAs, but that's, they're built out of census tracts, but you cannot get PUMS data for that. So CDTAs and NTAs are DCP-created geographies, and they aggregate census tracts up to a higher level, and they're much more reliable than using tract-level data. However, PUMAs were created for PUMS data. So the threshold for 100,000 people in an area, which means you sacrifice, you can get small group data, but you don't get small geography data.
Hi. As always, I need to learn how you make slides, because seeing this level of interaction and HTML in slides is awesome. It was interesting to see the household level detail in PUMS data.
Mm-hmm.
And is it true that you can only get that level of, I guess, household data in the PUMS data and not in the summary files?
Yes. So the summary file is already tabulated for you. So they take the data and they aggregate it up for you. I'm going to go back to that slide. The PUMS data is actually a so I didn't mention this before. So the ACS is the summary file is a sample. The PUMS file is actually 2/3 of the ACS. So it's slightly less reliable, but sometimes you cannot avoid not looking at PUMS data. So if you need any type of data on smaller populations and cross-tabulations, which you won't find in the summary file. So looking at this example here, for place of birth, I just get country of birth, and it's based, in the summary file, it's based on a national threshold. And with the PUMS data, you actually get the raw count. So, but with a little bit of edit, so we're not identifying people in the file. But you get, so for example, here I'm looking at people this person was born in South Carolina. You don't get that detail we don't get state of birth or individuals in the summary file. We can get country of birth for the foreign-born population. So there are many details available in the PUMS file that you will not get in the summary file.
I guess just to the household part, usually I imagine census blocks as the smallest geography of census data.
Mm-hmm.
But if you look at the PUMS data, you could see who lives together in certain households. So
these are, they say that they're actually actual respondents, but we're not actually seeing the respondents. They add some noise to the data and some edits, so you will not be able to identify individuals in the PUMS file, which is why the data are only released on the PUMA level, because we don't want to actually know who these people are. We can't go to Morningside Heights and say, okay, you're from Trinidad and you're from South Carolina.
Right.
So we can't identify them in the data.
Okay.
But we get individual records in order to be able to tabulate them and manipulate them so we can create our own cross tabs, so we can have get a better idea of what's happening in the city, but we're not seeing individuals themselves.
Thank you.
We have a couple more online questions. Adrian Nesta asks, thank you for the very interesting presentation. Have you worked with iPUMS to automate some of the PUMS data retrieval? From my understanding, it is a pretty good source, but I'm curious about your thoughts on it.
So PUMS is a great, PUMS, they may pronounce it iPUMS, but PUMS is a great resource for PUMS data. I have used it in the past. They're great at harmonizing data over time. So if you want consistent variables, I don't use a PUMS data set, partly because it's so easy to pull the data into our using the API. So it's the same data. They have different recodes. I prefer to recode. I guess I just like a hands-on approach, that I want more control over what I have, but PUMS is great. The interface is fantastic, and they have a lot of guidance for using the data. It's the same data, it's just they recode it a little bit differently. One thing I definitely don't use from PUMS is some of the household data, because the recodes with new variables, sometimes they fall into an NA, so you get a large NA category, and it's easier just to go to the actual PUMS file. But they're not different data sets, they're just processed. The PUMS processes the data. And what was the second?
Yeah, and another online question. Have you ever made maps comparing different boundaries? Is there a use for that kind of analysis? What subjects?
Could you repeat that?
Yeah, have you ever made maps comparing different boundaries?
Comparing different boundaries by, could you ask?
Yeah,
clarify?
Whoever asked this question, if you would like to clarify what you mean by different boundaries, that'd be great. In the meantime, I'll actually ask a question.
Okay.
Just so curious, where do these maps that you make end up? Like, how are they sort of for internal use to help with analysis? Are they shared and published somehow? And if so, how?
So both. We have, let's see, can I go to the Population Division's website from here? So a lot of our products are on our website. We do a lot of data analysis in-house, and we share it with other agencies. But let's see, trying to talk and type. Is that our site? Yeah. So we publish a lot of reports, so some of our maps go into the report. With PUMS data, unless it's language data, which is used for language access, because you get more detail in the PUMS file than you do in the summary file. The summary file only has 12 language families. They're not even individual languages. A few of them are individual, like Chinese and Arabic and Korean, for example. But the PUMS file has individual languages, so that's the only file that, I don't know why the site looks so.
Resources, as you scroll down, the resources or data.
Yeah.
One of those.
So they're in both. We don't have a home page here. You can't see our home page, but if you go to our resources page, we have several reports. So we publish the maps with analysis in the reports. We have on our census, so the 2020 census page is also a part of the population page. So we have several maps. So here, and then also on our geographies page. And of course, I'll show you Map Viewer as well. So in our resources page, we have guidance on using geographies. Here's our map reliability calculator, and I'll just jump to Map Viewer. And so maps without an analysis are here on Population Map Viewer. But most of our maps are part of other data products, except for standalone Map Viewer, and then also PFF has some basic maps and data in there. Some of it we just will send like a standalone map to another agency or whomever we're working with. But it's usually accompanied by some analysis. Did the person clarify what they meant by?
Well, actually, I have one follow-up myself first. So, like Map Viewer, what is actually creating this map under the hood? Like what?
So we use Experience Builder and ArcGIS.
Okay, cool.
So it's an Esri product.
Gotcha.
Using ArcGIS Online.
I've asked another follow-up to the online folk. So if we have any in-person questions.
Thanks. Just a twofold question.
Mm-hmm.
So one is, admittedly, we create a lot of maps, and also through your help, we've been able to publish a lot of population data. I'm Fuad, I'm from ACL.
You're hi.
Yeah, hey. And so admittedly, like we've never published or used margin of error data, so this is really helpful. But I was just wondering, how do you do the groupings of values and margin of error when you showed like the
map reliability calculator?
Exactly, yeah. So not just like how do you use the tool, but also like what does it mean to group values together, whether it's values or margin of error? Is it just like bigger values are grouped together, or is there some kind of behind-the-scenes calculation that's being done?
There is behind-the-scenes calculation done, but what I like to do is start with what's intuitive of let's see how the breaks work. When you actually use the calculator, it gives you, so you can customize your own breaks, but then there's another function which by quantile, so I didn't show that part. So you can see if you just drop the data in, and if they're reliable based on how many breaks that you have. And then you can use that as a jumping off point, because sometimes it's not very intuitive, like an equal interval or a quartile of what you're using. You just find the tool here. So if this were extended on the right, there are other, when you drop, it's automatically calculated, so you can see like equal interval and a quartile there. But you can also just play around with what makes sense. Sometimes the data that you have, you may only be able to have 3 classes or 2 classes. And so when you're mapping data, survey data, if it's not reliable, it's better just not to show an unreliable map. So if you're finding that when you're working with the breaks and you're not getting any reliable results, however you manipulate the breaks, then just don't map that data, because it will mislead people and result in some really bad inferences about the data.
There's obvious cases where the margin of error exceeds the value. We showed us the country of origin. I think there was a value of 7 for, I don't know, it's hard to see a little bit, 7 for country, for margin of error, and then there was like a value of 4 for the value. So that would be an obvious, but the not so obvious cases, how would you know if it's like too big of an error?
So we actually calculate significance. I can show you.
Yeah, sorry to
Well,
get so technical.
Yeah, well, we can talk about that later, but if you go to, for example, our language data that we put out, or actually any of all of our products that we put out, we actually calculate reliability, and so we gray out values that are unreliable. So that sometimes people need to see that, but just when they're grayed out, just don't make a big deal about it. So, but when you're mapping it, it's better and just not to show a bad map.
Gotcha.
Yeah.
Thanks so much.
All right, are there any other questions in-house? I guess no. Well, thank you, Donnise. Oh, we got one more online.
I believe the question is a little, sorry, I'm just interpreting in real time. It sounds like the question is more asking about literally comparing the boundaries, sort of like showing like how these boundaries are adjusting, and then added how Donnise spoke about misrepresenting or misleading information. So I think actually, like, if I can give a teeny bit of an answer, like I think population has put out a couple tools literally comparing the different geographies, right?
Yeah, I can actually pull up one from our website. So I wasn't able to embed it within the document, but now that we're online, I can just take a look here. So we have an atlas showing this is, if I move too quickly, this is on our resources, and then you click on geographies. We have an atlas that shows how the boundaries changed between 2010 and 2020, and that's in a story map. Here, I had a screenshot of the PUMAs, but you can actually see all of our geographies that we work with and how they've changed. So here with the slider, which is great. So on the...
Can I ask you to pause for 1 second?
Sure.
Because the slides are not being shared on Zoom right now.
Oh, okay. Do I have to make it full screen or, okay.
Jeff, if you're there, is there any way to get the visuals from the computer back on back on the Zoom call?
Okay. So on our website, you can look at the boundaries. So if it's not showing there, but if you go to nyc.gov/population, we show the boundary changes of the census geographies there. If you're mapping them, you would just have two maps next to each other if you're doing it yourself. Did that answer what they were?
That is very much what the person was asking
Okay.
about. And maybe, if they want to follow up for a link, or as you described, how they can find it. Hopefully they can get what they need.
Okay. Well, sometimes you need to see how they have changed. If you are mapping change, then you would want to harmonize the data and put them in one geography, because then it's not a comparison if you're looking at PUMA 10 and PUMA 20, and some of the numbers are the same. So that would be, you would get wild results if you're doing that. But you would want to harmonize your data. A lot of our data on our website, we have harmonized for those summary file data with the PUMS data, because we don't normally put that on our website. We also have another data product. It's the I'm going to butcher the acronym, EDDT, or EDDI. Yeah, thanks. Yeah, EDDI. So that has PUMS data, and then that data will be harmonized when it's when the tool is updated, the application is updated.
All right.
Okay.
Well, thank you, Donnise.
Thank you.